Sir, Shivaya sir.
Dr. Shakila?
Okay, okay, madam.
Sir, ma'am has went to call resource person, sir. Please wait, sir.
Okay, okay. Okay.
Just be there, sir. Maybe some
Okay,
audio
okay. No
issue.
problem, no problem.
Yeah, now is audible?
Yes, sir. It's already
Okay,
sir,
sorry.
please.
Okay. Uh, so first of all, I would like to thank you, Dr. Kuti Rani Madam, Dean and Professor. And also, I'd like to thank you very much, HOD, Department of Chemistry, Iswar sir. And I will also extend my thank you to Dr. Shakila Madam for inviting me to giving the lecture in this today insight of synthetic and patent prospective in organic chemistry. So once again, on behalf of SVNIT, I will thank you one and all. So today we'll talk about the glycoconjugates as a reactive probe for detection and image of selenocysteine in biological system. Okay.
Sir? Shivaya sir?
We will also discuss the basic principle of fluorescence. So why we want to use this fluorescence, okay? And the design and synthesis of glycoconjugates, how we can design the glycoconjugates for the selective detection of selenocysteine and also cysteine. And we will also discuss about the studies, the reactive probe for the selenocysteine in buffer solution, as well as in serum, biological serum. And also we will discuss about on paper strips, okay? And we'll discuss the main important thing is how we can tune the derivatization for the different amino acids. Like we are here, the cysteine and selenocysteine, and one can tune the derivatization. Okay, we can tune the electron withdrawing groups, and we can selectively synthesize the molecules for the selective amino acids. Okay, and finally we will discuss about bio applications. Okay, so before going to that, so why the amino acid detection is important, right? So this is very important topic because the amino acids are important role, biological role, because they are are important life because they have many functions in metabolism. All of you know this is very well basic uh, the topic, but so we have to the detection of amino acids. This is a emerging field. Okay.
Sir, we lost your voice again.
Cysteine are important and also selenocysteine is important. Okay, because among these thiol containing small molecules, like the cysteine amino acid, only the thiol containing amino acid is cysteine is playing very important role in living organisms and also are involved in number of biological processes. Okay, so that is why the cysteine contributes to various physiological process such as protein dimerization via formation of disulfide bond. Okay, and detoxification of heavy metal ions by metallothioneins. Okay, and also the acetylation of lysine residues. Okay, and electron transfer of iron sulfur clusters. You can see in the picture in the slide. So they are amino acid, especially cysteine, playing cysteinylation and also oxidative and catabolism, and also the cysteine play important role in low molecular weight disulfides because of sulfur sulfur bonds we can form, that is a sulfur disulfide bond. Okay, and also the cysteine is converted to uh, potent antioxidant like glutathione, so which act as a stoichiometric antioxidants to eliminate reactive oxygen species, because in our body in the tissue, so there are a lot of biochemical reactions are occur. So in the during the chemical reactions there are a lot of the reactive this is very important biological essential element. Okay, and this amino acid is genetically encoded by UGA in mammalian tissue. Okay, and if you think about this selenium is a biologically essential microelements. Okay, this is all of you know very well. But so this selenium, the selenocysteine is playing very important role in biological functions. Okay, is especially for cancer prevention. Okay, and immune response and also inflammation protection. Okay, and one of the important the selenocysteine function is thyroid regulation. Okay, and if we have some deficiency in the selenium, that is the selenocysteine, so there is a problem of fertility. Okay, and also brain function. So this all the biological functions are associated with the selenocysteine concentration in the human body. Okay, and the selenium is a constant of redox active enzyme. Okay, especially such as glutathione peroxidase. Okay, and thioredoxin reductase. So these two enzymes are very important in our biological systems. Okay, so these two systems are regulated by this selenocysteine. For example, if we have an inappropriate level, so that means either deficiency or you have more concentration, so that is inappropriate level of selenocysteine. Hello.
సార్ అక్కడక్కడ మీ వాయిస్ బ్రేక్ అవుతుంది సార్ సార్ అక్కడ ఇప్పటికీ 4 టైమ్స్ అయింది.
అవును మేడం. ఓకే ఓకే.
ఓకే సార్ ప్లీజ్ సార్.
Is it okay? Audible now? Sorry, some net.
Yes, sir.
Yeah.
Yeah, now it is audible.
sometimes maybe some net issues are there. I don't know. Okay, because yeah, you can just send me message. You can call me whenever if you don't get the voice properly. So if as I said, the deficiency or high concentration of these biomolecules can result in abnormal biological functions or developmental. Okay, you can see that either these amino acids, either low concentration or high concentration, both can leads to a death or abnormal biological functions. So, so that means here to maintain the optimum concentration, so very important. So how to identify the optimum concentration in the biological samples? So that is very important. Okay, so for that, so one can detect optimum methods are there. So there are various methods are there. Among these methods, this fluorescence method is a technique. So this is based on optical signal have proven to be most useful as compared to other analytical techniques. Okay, so you can see in the Jablonski diagram, when it absorbs the energy, it will go to excited state, and when it is coming to the ground state, so that will emit the fluorescence light. Okay, so that is why this fluorescence is a rapid and facile detection method and attracted increasing attention during the past 2 decades because of its high sensitivity and selectivity and also low detection limit. Okay, so that means even if you have the sample, the biological samples are even nanomolar concentration, so we can detect by using this fluorescence technique. Okay, and here the optical sensors generally exhibit change in the fluorescence, okay, or even the ultraviolet visible spectral appearance, because sometimes even you can detect by our naked eye, because it will change the color properties of the receptor in the solution or in like in the coated paper strips. Okay, so that is why this leading to an like some chip material type, nanomaterial upon interaction with the guest species. Okay. Yes, madam.
సార్ మీరు స్లైడ్ చేంజ్ చేసినప్పుడు ఇది పోతుంది సార్
Okay, okay, okay.
వాయిస్ పోతుంది మీరు స్లైడ్ స్టాప్ చేసి మళ్ళీ రీషేర్ చేస్తారా లేకపోతే ఫుల్ స్క్రీన్ లేకుండా చేసినా అని వస్తుందేమో చూడాలి సార్
Okay, madam. Okay, okay. Full screen off చేయమంటారా?
ఫుల్ స్క్రీన్ ఆఫ్ చేసి చూడండి అప్పుడు కూడా ఇలానే అయితే స్క్రీన్ షేరింగ్ స్టార్ట్ చేసి మళ్ళీ చేయండి
Okay, okay, okay.
ఓకే సార్
So, am I audible, madam?
Yes, sir. Yes, sir.
Yeah, I just now switch off the full screen. So here I am just will give the brief idea about this design of these glycoconjugates, because where the biomolecule recognition is a specific interaction so between the two molecules. Okay, so that is one is a receptor, one is a donor. Okay, so which both are complementary in the like geometry or some electronic features. So due to this interaction there will be a change in the signal in the fluorescence or in on the other techniques. So basically, so there are different kinds of interactions in the biomolecular. Covalent binding, and also some uh, cation pi interactions. Okay, and there are covalent binding on PET PET process also. There are various kinds of interactions. The recognition process are there, but today I will focus on the nucleophilic aromatic substitution reactions. Okay, and here if you see that the design of the glycoconjugate. So why do we need the glycoconjugate carbohydrate based moiety here? Because if you have this glyco moiety, that is carbohydrate glucose moiety, okay, so that will increase the solubility and reduce the cytotoxicity. Okay, and so it can, one more important factor is the selective internalization by a specific cell target. You know, all of you, on the cell surface you have a recognition domain, carbohydrate recognition domain. So each carbohydrate will have a specific recognition domain, like glucose, galactose, fructose. So there are different kinds of recognition domains are there and specific cells. So that is why if we have the glycomoiety, so that will selectively internalization by a specific cell target. And also I have the fluorescent moiety, which is a dancyl chloride, that the dancyl moiety, and one more act as a initially the internal charge transfer. Due to that, so there is a weak fluorescence. And once if it is on the reaction with the nucleophile, that is a cysteine or selenocysteine, so that will give the that will release the fluorescent moiety. Okay, so here the synthesis of and characterization of glycoconjugates. So this is, as I said in the previous slide, it is easy to design the molecule, but while the synthesis of this molecule is very difficult, we have to go through number of steps. Okay, I started with the dancyl chloride. Okay, and then propylamine. In the triethylamine it act as a base in the dichloromethane solvent at room temperature 1 hour. So it will give the dancyl conjugate. Okay, that is one step. In the second step, in the second part, so I started with the glucose, and initially I protected all the groups, okay, by using acetic anhydride. After that, I used 33% of HBr in acetic acid, so that will selectively the substitution at anomeric position at C1 position. So that means bromo derivative of glucose. All this is in situ one part reaction. So that is why in the same reaction, without isolation, I have added the sodium azide and the reflux 8 hours, or even you can isolate because it is unstable, and then we have to quickly do the reaction. So add sodium azide, and then reflux 8 hours, and finally you will get a very good crystalline white compound. So that is the all you can see that the all OH groups are protected with acetyl, okay, acetyl anhydride, and only at C1 position you got the azide N3. Okay, so once you get the one side propyl dancyl derivative and another side is azide glucose derivative, so now both are connected through a click reaction, so that is a 1,3 dipolar addition reaction by using copper sulfate and sodium ascorbate. So these two act as a this sodium ascorbate can reduce the copper sulfate from copper 2 to copper 1. So this copper metal act as a here catalyst. Okay, in the solvent 1:1 ratio in tertiary butanol and water at room temperature 12 hours reaction. And finally you can see the triazole linked derivative, triazole linked glycoconjugate of dancyl moiety, a triazole link. So we have isolated extracted with DCM, okay, dichloromethane, and then purified by a chromatographic method, and finally you can get a pure yellow color compound. So that is glycoconjugate triazole linked densyl derivative. And on just above I have synthesized that is a C1 molecule, that is a control molecule, so which is absence of glucose moiety, because we want to check the role of glucose. Okay, so that is a control molecule. And in the continuation of the synthesis of this molecule, the triazole linked dancyl derivative. Now here I want to introduce the 2,4-dinitrosulfonyl chloride. So for this, so initially I have dissolved the conjugate in THF, and also this 2,4-dinitrobenzene sulfonyl chloride also I have dissolved in the THF. Okay, and I added this 2,4-sulfonyl chloride in dropwise to the reaction mixture at 0 degrees Celsius. So after that I leave at for 1 hour reaction. So because here I use this dancyl sulfonyl chloride with excess, because the sodium hydroxide act as a base, so it abstract the proton from NH, so that will substitute the chloride, and finally we will get the uh, 2,4-dinitrobenzene sulfonyl chloride attached glycoconjugate. At the end, finally, you have to deprotect the acetyl groups. So that is very important, because the solubility, whatever we have discussed, the role of carbohydrate moiety. So for that, we have to deprotect uh, the acetyl groups. So for that, I have used the anhydrous methanol and 0.2 molar acetyl chloride, room temperature and 12 hours. So this is a very tricky reaction. So because if you use some base, okay, so if you go into the basic condition, so this 2,4-dinitrosulfonyl moiety again will deprotect. So that means again this moiety will release. So that is why I have faced a number of problems in this step, but finally I have optimized this condition. So that is anhydrous methanol and then 0.2 molar acetyl chloride at room temperature. So this reaction you can easily monitor by using TLC, that is thin layer chromatographic method. So because both are, so you can easily distinguish by polarity, because once if you deprotect, so that will be more polar, and the protected molecule is non-polar in nature. So that is why whether the reaction is completed or not, so that we can easily monitor by the TLC chromatographic method. So once that is over, so we can easily isolate the final compound. Okay, so once you have done synthesis after going through number of steps, so now it is very important you have to look the applicability of this conjugate. Okay, applicability of this organic molecule. So that is very important. So for that, so initially I have done the optimization of the reaction condition for the fluorescence studies. So whether how much time, okay, that the time take will react with this cysteine, okay, with this molecule, and also the pH, the optimization of the reaction pH also I have done. Okay, so here you can see the in the spectrum, fluorescence spectrum, from 0 minute to it almost optimized the uh, 240 minutes. That means almost within 4 hours completely optimizes. You can see that. But if you draw the graph, time versus intensity, after 50 minutes, after like 30 to 40 minutes, it's completely saturated. So okay, even if you go beyond 240 minutes, so there is no change in the fluorescence. So that is means the reaction time we have optimized, and also the reaction pH. So at what pH it will give the more intensity. So that means pH versus the intensity. If you see that for graph, okay, at the biological pH, so the pH 6 to 10, it is the steady without a change in the fluorescence intensity. So that means the fluorescence spectra, both the reaction and the time dependent on pH dependent, both as a function of time as well as a pH, it will give better result, like so we can study for the further in the biological systems. So the reacting the molecule in aqueous solution, the pH within the range of p 6 to 10, and within the like response time, incubation time, that is 30 to 40 minutes. Okay, so once we have optimized these reaction conditions, then I have done several studies, fluorescence studies. So if you look at the initial of this fluorescence, the charge transfer from the electron rich moiety, so that is the dancyl moiety. Okay, so the electron, once if it is charge transfer from the dancyl moiety to electron deficient moiety, so obviously the fluorescence is very 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 low. Okay, so this studies I have done in buffer solution, so that is HEPS buffer solution. The concentration of this molecule is 5 micromolar. I have excited at 360 nanometer. Okay, and as I said, the molecule initially exhibits very very weak emission at 550 nanometer. You can see the in the fluorescence emission spectra. Okay, because of intramolecular charge transfer. Once if you add the cysteine, okay, the amino acid 16 result in the enhancement. As you can see, the by increasing the concentration of cysteine, the gradual increase in the fluorescence emission intensity. You can see that several fold of as a function of added cysteine concentration, because this the electron withdrawing, the electron deficient moiety 2,4 dinitro the 2,4 nitro dinitro benzene moiety is released from the molecule. Okay, so that the mechanism we will discuss in the coming slide. Okay, and similarly I have tested with the number of amino acids. You can see among these 20 amino acids I have tested. Okay, you can mole ratio. You can see that almost 10 1 is to 10 mole ratio is almost highest fluorescence intensity. Okay, if you look at the color of the solutions, you can see the visibly we can distinguish the cysteine among 20 amino acids. Okay, okay, you can see in the insect of the color of the oils. Okay, Only in presence of cysteine, so there is a greenish yellow color we can observe. So that means the L can be has been employed to recognize cysteine. So this molecule can selectively recognize the cysteine by number of volt, like switch on in the fluorescence among 20 different amino acids in buffer solution, that is a physiological pH. So the physiological pH around 7.4 physiological pH. And also by using this molecule, we can detect the minimum concentration. So that is 2.5 into 10 power of 7 molar. Okay, so that that much minimum concentration we can detect by using this molecule. And also we have tested with the different thiol containing molecules. Okay, you can see in this graph. So
షేర్ చేయండి సార్, మళ్ళీ అలాగే అవుతుంది.
okay, okay, madam. Okay.
ఓకే.
Participants, I think there is some new issue. So we will stop sharing this slide now and reshare. Please be patient.
Now is fine, madam.
Yes, sir, now it is audible.
Yeah, some maybe there. Okay, so in this slide you can see that the cysteine is more reactive towards the molecule compared to other thiols. So and also if you see that the color, that is a native form of protein, because there you have a lot of sulfur sulfur bond, that is a disulfide bond. Okay, so that is like a DT oxidized form and glutathione oxidized. In that case there is no change in the fluorescence intensity of the molecule, because so there is no reactive the thiol groups. Okay, so there is or disulfide. Okay, and also you can see in the absorbance, so there is a clear change in the absorbance peaks around that 340 around 350 nanometer. The absorbance increased around 290 nanometer. The absorbance is decreased, and you can clearly see the isobistic points where 240 nanometer and also 320 nanometers and also 420 nanometers. Okay, so that indicates that so there is a clear-cut interaction of these amino acids with this molecule. Okay, and here, so this is very important. So the reaction mechanism, so whatever we are discussing, okay, how it is interacting with this molecule with the cysteine, and we have studied with using proton NMR and also ESIM mass spectrometry. Okay, so you look at the initial molecule. So the initial molecule, the mass spectrum is the molecular weight is 746. Okay, and you can see that the NMR spectrum are it started with one. Okay, and you see that once reacting with nucleophile, Okay, so there is intermediate. At intermediate, you can see that more number of complex NMR signals. Okay, so that means so there is a mixture of these compounds. So and at the end, finally, okay, so this is other further supported our studies. Okay, and next we have done the applicability, the intracellular thiol detection by using fluorescence microscopy. Okay, so I have used two different cell lines here, the FZ2 cell lines and the HeLa cell lines. So the molecule concentration is about 20 microgram in both the cases. So once if it is incubated, so it will use the fluorescence in the cell because the cell, okay, the intramolecular thiol concentration is much higher as, okay, so that is why once if it is incubated, okay, so that will reaction within the cell, so that is very important. So this within the cell you can see the fluorescence, but how do you know whether it is selectively reacting with the thiol, that means the cysteine? So for that I have done the confirmation study. So this n-ethyl melamide, okay, n-ethyl melamide n-ethyl melamide is used to consume the intracellular thiol. So this is a chemical which consumes the all intracellular thiols. So that will give the whether the our molecule is reacting with the specifically to cysteine. So for that we can see that so there is no fluorescence in the cell. So that means our molecule is specifically reacting with the as a time function as well as a concentration function in both study. So the ligand, the molecule is effective intracellular thioimmunizing agent with a good cell permeability. That means so it can enter into the cell, and also in the both the cell lines like FZ2 cells and HeLa cells, both are cancerous cells, are viable up to 50 micromolar concentration up to 12 hours. So you can see the after 12 hours the cell viability is decreasing. Okay, even the concentration also, when you see that after 50 micromolar, the cell viability is decreased. So that means this molecule can viable up to 50 micromolar and 12 hours. And these results we have published in the analyst. And if you want more details, you can go through this paper. Next challenge is, so as I said, the inside the cell, the concentration of cysteine is much higher as compared to selenocysteine. Selenocysteine is a very less concentration, is approximately 13 to 16 milligram entire the body, the concentration of selenocysteine. So that means that this is very low concentration. It's very difficult to detect the selenocysteine in presence of other molecules, other biomolecules. So that is why it is a very big challenge to the researchers for the development of small molecular probes for the selective detection of selenocysteine, even in presence of biological in these two. Okay, so you look at the pKa values of these two amino acids. The cysteine, the pKa value is 8.3, and selenocysteine pKa value is 5.2. Okay, so this the difference in the pKa value. Okay, the selenocysteine is expected to exhibit high reactivity. So all of you know that this pK value, if you have lower, so that means a stronger nucleophilic nature. So that means as compared to cysteine, the selenocysteine can act as a strong nucleophile. So by using this difference in the pK value, so that will provide an opportunity, okay, for the researchers to develop a system for the selective detection of the selenocysteine, right? So basically this difference in the pK value, so this will give a good opportunity to develop the molecular probes. So for that, so I have done the effect of pH on the same molecule. You can see here the effect of pH, because again the nucleophilicity will depending on the pH, right? Okay, so you can see that in the case of selenocysteine, okay, in the blue color, the graph spectra, that will give at 5.8 the pH at give maximum intensity. But in case of cysteine, okay, so it will give, as already we have discussed, the effect of pH. So that is approximately say 7 to 10. It will give maximum intensity. Okay. Because of this the pH effect, which prevents its in vivo application. Okay. So now we have to tune the molecule, because if using the same molecule, we cannot differentiate at physiological pH these two amino acids. But because, as I said, this molecule, it can react with cysteine as well as selenocysteine. So that means it is not suitable. Okay, so this is not selective for the both the amino acids. And next, I have mono, this is derivative. Now I have changed the mono derivative, only one at para position, nitro, the para position, the nitro group. So that is mono nitro derivative of benzene sulfonyl. Okay, so for this synthesis, again the same procedure as I explained in the previous slide. Okay, for the mono derivative of nitrogen benzene. Okay, in this molecule, so this is not reacting with the cysteine, because we have tuned the electron withdrawing group. Okay, because of this cysteine is a lower nucleophilic in nature than the selenocysteine. So but selenocysteine can react with this mono derivative and can give the fluorescence. So for that we have studied by using fluorescence and number of studies. So you can see that the fluorescence spectra, concentration added. Okay, but what about the cysteine? As I said, the cysteine is no reaction, so there is no change in the fluorescence intensity. So that means there is no reaction is occurring between cysteine and mono derivative of molecule. Okay, the mono derivative of glycoconjugate. So by using this molecule, which we can detect the detection limit up to 1.5, that means 25 ppb of selenocysteine. So this is it's a very good the molecule which we can detect the even 25 ppb. That means even nanomolar range, which we can detect the selenocysteine in our biological system. Okay. And you can see here and also here I have studied with different 20 amino acids. Okay. Okay. Only among these 20 amino acids, which only shows the fluorescence intensity, which color change in case of selenocysteine. Okay, that means which you can differentiate the selenocysteine among naturally occurring amino acids. And also you can we can detect by our naked eye by changing the color from non-fluorescent to a greenish yellow only in case of selenocysteine. Okay, you can see that on the just on the top of the histogram. You can see that only in case of selenocysteine we can see the visually color change, because if you the reaction of thiol as well as selenium containing, because as I said, in our biological system we have different thiol containing molecules, the homocysteine, glutathione, DTT, and cysteine, and also some other selenium compounds. Okay, and you have various selenium dioxide and sodium selenium dioxide and benzene selenol. So there are different kinds of compounds we have in the thiol as well as selenium containing compounds. You can see in the from the histogram. Okay, so only in case of the selenocysteine, it you can see the large number of change in the fluorescence intensity. Okay, and also you can see the only because here the benzene selenol is also the free selenium content, that is also shows fluorescence intensity. So this study clearly supports the fact that the selenocysteine is more reactive towards the molecule or synthesized molecule compared to all other selenium as well as thiol containing compounds. And also here also we have studied by using the reaction mechanism and how it reaction proceeds, also by using proton NMR spectroscopy. As I said, so you can see the NMR spectrum of the starting molecule. Okay, once the selenocysteine is added to the reaction mixture, so that is in the okay. And to check the whether we can develop the and cellulose paper strip technology. So okay, for that initially I just drop casted the compound of this molecule on the paper strip. Okay, so after that I just leave at room temperature to dry to dry the solvent. Okay, so after that, and I drop casted this selenocysteine on the same on the molecule. Okay, you can see that the photographs under UV light, that is a 365 nanometer lamp of the probe coated strip. You can see that with increasing the concentration of selenocysteine, you can see by visually there is increase in the color intensity. Okay, so that means even on the silica, that is a paper strip coated compound also, which we can use for the detection of the selenocysteine. So this is because this is easy to prepare, and also this is a very inexpensive, cheap, and use and through method which we have developed, and we can monitor the large number of samples because it cost maybe less than 5 rupees. Okay, so that is why which inexpensive and easy and use and throw method which we have developed. Step, and that is why this technology can be used for large scale screening of biological samples routinely, and also the detection of selenocysteine in the serum sample by using fluorescence. Okay, because on the, as I said, in the biological samples the selenocysteine is so very low. So by, and in the serum samples which have taken the fertile bovine serum, okay, so that is 1 ml of serum and 2 ml of buffer sample, and after that we have added a selenocysteine, and you can see that there is increasing the fluorescence intensity. So that means, so which you can easily detect the selenocysteine even in the biological serum samples. Okay, and further, because as I said, the selenocysteine is in the, as I said, the selenocysteine concentration in the tissue is a very low. Okay, so that is endogenously. So that means we have to add, that means we have to add the selenocysteine into the cell. So that is in, you have to incubate and then you have to study, because initially the cell containing very low concentration of selenocysteine, you can see that the fluorescence intensity, there is no fluorescence. Okay, ligand as well as selenocysteine, so no fluorescence. And you can see that even with cysteine, no fluorescence. As I said, the cysteine is no reaction. How to detect the in the in vivo, so that is without addition of selenocysteine. As I said, selenocysteine is a metabolic product of sodium selenite. Okay, so that means if you incubate the sodium selenite, so that is a supplement of the cell with the sodium selenite, so that could significantly increase the selenocysteine level in the cell, because you are supplementing with the sodium selenate, then you are increasing the selenocysteine concentration levels in the cell. So first, initially I've done with the time dependent study. Okay, so after incubation of the sodium selenite, okay, so you see that 1 hour and 3 hours and 6 hours and 12 hours, you can see the gradual change in the fluorescence intensity under, this is under the fluorescence the imaging. You can see the time dependent. So the intensity of the cell, the fluorescence intensity of the cell imaging is gradual increases. Also, I have done the concentration dependent study of the sodium selenate. Okay, so initially I incubated 5 micromolar, 10 micromolar, and 15 micromolar, 20 micromolar. You can see if increasing the concentration of the sodium selenite, so that is the supplement of the cell, so that could increase the, significantly increase the selenocysteine levels in the cell. So you can see the intensity of the and other studies of the synthesis of the molecules also. And also we have done, okay, and also we have done number of different compounds, okay, because you can see that the number of the lot of almost we have 5 different products, the different molecules we have synthesized by varying the derivatization, the tuning the derivatization on the benzene sulfonyl moiety. Okay, so L1, you look at the L1, so that is a dinitro, and L2 is a pentafluoro derivative, and L3 mononitro, and L4 monofluoro, and L5 that is electron donor groups, that is methyl group. Okay, so I am studying all these molecules and compiling the data here. Okay, and L1, if you look at the L1, so that is dinitro derivative. So this dinitro derivative is both towards, both sensitive over towards the cysteine as well as selenocysteine. So by using L1, we cannot differentiate the cysteine or selenocysteine. And selectivity, that means the selectivity, no selectivity, because it is reacting with the both the compounds. But if you look at the L2 compounds, again 5 fluorine groups, again the fluorine is a strong electron withdrawing groups. Okay, so the 5, the pentafluorobenzene moiety. So again this is also sensitive. Okay, easily differentiate the selenocysteine over other biological or thiol or amino acids in the physiological pH. But come to the L4, again the monofluoro compound. Okay, so here the selectivity is there because it is selective towards the selenocysteine, but sensitivity is very less. Okay, sensitivity means the reaction, the substitution reaction is very less. The sensitivity is less, so that means the reaction proceeds very, very slow because the fluorine, the electron withdrawing capacity is less as compared to nitro group. And fifth molecule, that is L5 molecule, is the donor group. Okay, that is not electron withdrawing group. So that is why there is no sensitivity and also there is no selectivity. That means by using this L5 molecule, which we cannot detect whether the selenocysteine or cysteine. So that means no reaction will occur. And finally, you can see that tuning the electron withdrawing group on the benzene sulfonyl moiety, okay, of this trizo-linked glyco moiety of the dancyl derivative, which we can easily distinguish the selenocysteine as well as cysteine among the biologically important amino acids. Okay. And finally, I would like to thank you very much for your kind attention, and also I'll extend my thank you to for any questions.
Thank you very much, sir.
Yeah.
This was really very interesting talk. Yes, participants, please post your questions in chat box so that I will read out them to the speaker and you can answer your questions. You can clarify your doubts. Shivaya sir,
Yes,
was
madam.
really very great lecture. I hope this is very, very interesting also. I'm sure many students have got benefited with this.
Yeah.
Except for few voice disturbances, otherwise there is no problem.
Yes,
I
yes,
don't
ma'am.
know, some network issue or whatever, but
Yeah.
so participants, whenever you felt like some content is missed because of this voice issue, please post such issues
Yeah.
here
Please
so
post
that we
your
can,
questions. Yeah.
yeah,
Please
so
post the
that we can
questions.
discuss and clarify. Your
Yes,
question
yes.
may be useful for the others also. You please go ahead and post your questions. So
And
your talk is really
Shakila,
interesting.
Or
So
you can directly unmute the speaker, like a
yeah,
participant. You can they can ask me the questions directly.
yeah, that is also allowed. So you can now
Please.
we have given chance to all the participants. You have the you can unmute yourself and talk to the speaker directly. Yes, please introduce your with your name.
Dr.
Yes,
Shakila,
sir. Yes, sir.
you can go through the chat box also.
Yes, yes, sir.
Okay.
Yeah, we have a question, sir, here in the chat box. So in the first synthetic scheme, how did you selectively protected the OH groups in carbohydrate unit?
Yeah, so there is no, actually I did not selectively protected. Okay, I have protected all the OH groups. Okay, so because I added acetyl groups. Okay, so that will protect all the OH groups. Okay, and then after that I added HBr. Okay,
Okay, sir.
hydrogen bromide. So the HBr, because of this monomeric effect at C1 position, it will selectively react at the C1 position, because so that is the monomeric effect in the carbohydrate. Okay, so that will give the at C1 position mono bromo derivative. Okay, so after that I added sodium azide. Okay, and then you will get at C1 position azide, and remaining all other OH groups are protected.
Yes, sir. Thank you. Yes, any more students, research scholars? You can unmute, tell
Yeah, you
your
can.
name.
Yeah, you can
Yeah,
unmute and you can speak directly,
yeah,
because, as I said, madam, some the internet technical issues are there. So please ask.
yeah, yeah. Any point
Addition.
you, if you feel like you have missed, you please ask.
No, no. Somebody
There
said,
is one
yeah,
more question, sir.
yeah, yeah.
Addition of aqueous HBr, wouldn't it open the ring of carbohydrate?
Yeah, so that will open the ring. Okay, so that will open the ring. But after adding that sodium azide, and the finally when isolate the compound, okay, so you will get the closed ring derivative, because in the during the reaction, okay, in the HBr, after addition of the HBr, so during the reaction, so it will open up the ring, and it will substitute the bromine with sodium. So that will sodium NaBr, that is the byproduct, and the azide, which will come to the at C1 position. So that will give the azide of the glucose derivative. And finally, you will get the, when you are isolating the crystal of the, you will get the crystalline compound of azide, the protected glucose. So that will end of the product, you will get the cyclic of the glucose. Yes, you are right. Best in the during the reaction, when you are addition of aqueous Br, so it will open the ring of the carbohydrate.
There is one more question from Dr.
Yeah.
Asha Jansi. She is a faculty in present chemistry department.
Yes.
She's asking, in most of the biological related studies, selenium is preferably used. Why not tellurium?
Selenium, actually, as I said, the selenium is playing very biological process, playing very important role. As I said, glutathione reductase. This is a constituent of many enzymes. As you know, the thyroid function is mainly controlled by this selenium concentration in the human tissue. But as compared to this tellurium, tellurium, the biological, the role is, and compared to the selenium is not like selenium, because tellurium is not involved in the many biological functions. Okay, even this is the tellurium is not essential micronutrient for the human tissue. Okay, because the selenium is the essential micronutrient for the human body. So that is why the most of the biological related studies have done with the selenium. So not actually we are more on the selenium, not on the tellurium, because as I said, the tellurium is not essential micronutrient, and also the tellurium is not playing an important role in the biological functions. Yeah.
So there is another question from a
Yeah.
PhD research scholar from present. She is Rosina Begum. She is asking, what is the role of triazole?
Okay, so actually here the role of thiazole is linking. So that is a linker. It acts as a linker between the glucose moiety and the fluorescent moiety. Okay, so which is the dancyl chloride and the glucose moiety. So these two moiety we have to link together. So for that I have used this triazole moiety, because this is very facile and easy to synthesize by using a triazole, because it is a very facile reaction. So you will get more than 80% yield of this triazole linked product. So that is why the role of this triazole is only a linker, act as a linker between the fluorescent moiety, which is the dancyl chloride, and glucose moiety. Okay.
Sir. So there is one more question from I think Venkat. He is a MSc student here.
Yeah.
Sir, which dye is used in your studies for the cellular imaging, the green
Yeah.
color images?
Yeah, as I said, the dancyl moiety, which you can see that as I said, the dancyl moiety is attached to the glucose. So the green, so the dancyl moiety will give the emission at 520 or 540 nanometer. So that will emit the green color. So and no need any other color dyes for the cell imaging study, because already this molecule is having the fluorescent moiety. Okay, the fluorescent probe. Okay, so as I said, the electron withdrawing group is there. So once it is released from the molecule, so automatically the dancyl, that is the fluorescent probe, so that will give the green color image. So there is no any addition of the probe. Okay, any color imaging agent. So
Okay,
that
sir.
is a dancyl moiety.
Okay. Okay. Dr. Asha Johnson, she's again asking, for the benefit of students, please explain about the isobestic points observed during the interaction studies of probe with cysteine selenium.
Yeah, so here the isobestic points means at the isobestic points, all the spectral lines having the same absorption intensity. Okay, so at the particular wave number, okay, you take any wave number, as I said, 340 on 420 nanometer. Okay, so at this wave length, okay, at this wave number at 420 nanometer or 340 nanometer, so there is no change in the absorption intensity. All the concentrations, all the spectrals having the same absorption. So that point is called isobestic points. So if we have the same observed in the fluorescence in the spectra, okay, so that is also isoemissive point. So that is different from the isobestic point. So that is isoemissive point, because in the emission spectra, if you observe the same intensity, fluorescence intensity at the a particular nanometer, so that is called isoemissive point. In the absorption, if you have observed the same absorbance at a particular wavelength, so that is called isobestic point.
Okay, sir. Sir, Miss Rosina Begum, research scholar here, she is asking, if you use methylene linker instead of triazole, what will happen in sensor activity? sensor behavior.
As I said, the triazole role is only a linker. Okay, even if you use a methylene linker, so that will also, it will give the same result. So there is no role of linker. Only I have used the linker because, as I said, the triazole reaction is a very facile, so that will give more good yield of the product. Okay, so that purpose only I have used this triazole linker. Even if you can use this methylene linker also. Okay, which I have not tried. Okay, because of as I said, the to see the product yield. Okay, so even if you use the methylene linker, so obviously similar result you will observe.
Okay. Okay, there is one more question from Dr. Asha. Please mention the lowest detection limit achieved in this work towards cysteine detection.
Yeah, so lowest that is lowest detection limit means a minimum concentration which can detect by using our molecule. Okay, so let's say I have done the study especially using this both the fluorescence and absorption studies. So initially I have not added any cysteine, and I started as low as like I went to picomolar range. I added 10 picomolar cysteine. So and then I recorded the spectra. So whether there is a change in the spectra, and I increased the concentration 100 picomolar, 1 nanomolar, 10 nanomolar, then 100 nanomolar, micromolar. So like that. So and from 0 to I increase the concentration of cysteine at where we can significantly observe the change in the spectra in the fluorescence emission. So that is called a detection limit. Okay, or you can say that lowest detection limit LOD, or the minimum concentration of a molecule can detect the cysteine.
Yes, sir. Okay, sir. Next question is, what kind of cells are used in your studies? After the experiments, do the cells have same metabolic activity?
I actually, in this study, we have used two different cell lines. One is a HeLa cell. Both are cancer cells. Okay. One is a HeLa cells and Hep2 cells. Okay. Both are cancer cells we have used. And also some normal cells, healthy cells also we have used, but that studies I have not presented here. Okay. So as I said, both cells used after incubation of this compound. Okay, both the cell lines can up to have 50 micromolar concentration, the cell viability. So beyond that, so the cell viability is, as I said, gradually decreased, and the cells is not having the same metabolic activity. Okay, so after incubation of this compound into the cell lines, they did not exhibit the same metabolic activity. So that means beyond the concentration, so there is a the effect of the compound. So up to the 50 micromolar, the cell can the cells have the same metabolic activity. Okay, so that means we can incubate till the 50 micromolar concentration up to the 12 hours, and beyond that again the cell viability is decreased. That means which is not having the same metabolic activity.
Yes, sir. One more question. Is the probe used in this work is aquasoluble, water soluble? Which medium is used for bioimaging studies?
Yes, yes, yes. So this is a very good question. As I said, in the designing itself, our molecule, we have attached the water soluble moiety. So that is glucose. All of you know very well, because this glucose is having many number of OH groups. Okay. So due to that, it will increase the solubility. Okay. So the solubility increases, also it reduces the toxicity. Okay, so that is why the our molecule is completely water soluble. Okay, completely, even if we take the 1 milligram and add 1 ml of water, so it immediately dissolves the compound. That is why, due to this increasing the solubility, all the studies, cellular studies, all experiments we have done in the buffer solution at pH 7.4 at physiological concentration, the physiological pH. We have used HPGS buffer, also PBS buffer in the both studies, in the buffer solution, aqueous buffer solution in water. As I said, in the lot of reported molecules are done in the organic solvents, because all of you know that organic solvents are toxic to the biological system. That is why purposely we have designed these molecules to improve the water solubility. We want to study the in water, so that is why we have attached this glucose moiety to improve the solubility and to reduce the toxicity. That results the entire the molecule can easily dissolve in water in the buffer solution. That is why we have done all the studies, experiments in the buffer solution.
Okay, sir. Yes, sir. There is a compliment. Excellent work and nice presentation with clarity. Thank you, sir. Yeah. So now we still have some time for discussion. Please, participants, unmute yourself and start discussing with sir.
Please, still, if you have any questions, please send a mail. Okay, ma'am.
Yeah.
So you can
Yeah, sure.
share my detail. So if you have
Yes,
still
yes.
any questions, please send the email. Obviously, I will respond to that mail.
Yeah, sure, sir. Participants, there is a feedback form shared in the chat box. Please fill that one. Your feedback is very, very important for us.
Professor Sivaya?
Yes, sir.
Sir, thank you very much for your elaborate and informative lecture that induced our students and scholars to ask very good questions.
Yes,
That
sir.
itself shows. Okay,
Yes.
sir. Now, one more request. Now, actually, we have that bare minimum facility only in our department to do the research work. If you are
Okay.
extending your infra, that instrumental facilities available in your NIT, we can
Yeah.
have joint publication, joint conference, something like that. We can do. We can continue our in collaboration.
Sure, sir. Sure, sir. Only we have lack of this cell imaging studies. We don't have here, and remaining other studies we have.
No, is there any possibility of doing the cell imaging studies?
No, sir. We don't have that cell imaging studies.
That you have
Even
enough.
in my studies, I have done with collaboration in the IIT Bombay in the during the PhD with
Okay,
the
okay.
bio
Image.
school. Yeah,
Yes,
in the
yes.
bio school.
Okay, now because the work is so very interesting,
Yeah,
our
yes,
students
sir.
are also doing that type of work, but we don't have that application study. We could.
Exactly, exactly. You're right, sir. You're right, sir. Because that we need some specialists,
Yes,
bio cell imaging who handle the cell culture.
yes.
Okay. So and also we need sophisticated the
Instrument,
microscope image.
microscopy.
Yeah. So that we actually I have done with collaboration in the bio school. So
Okay, sir. Thank you.
yeah, currently, so remaining other studies, I can extend whatever possibility studies we need. I can extend my support.
Okay, sir. Thank you, sir.
Yeah.
Some student can do some internships, sir, like project work there. Nowadays, actually,
Yeah,
mainly
yeah,
what.
yeah, sure, sure. They can do internship or they can do 6 months for their project also.
Yes, yes. Here in our MSc, we have allotted the final semester dedicated only for doing the project work. They can come
Yes,
there and do the work,
sure,
and we
sure,
can
sure.
have joint publication. In that way,
No,
we
sure.
will continue our collaboration.
Exactly, sir. No problem. So you can, I will extend, as I said, my full support to the students so they can come and work either 2 months or 6 months, because one summer research fellowship is there. So encourage the students to apply the summer research fellowship, because
Yes,
in
sir.
that case they will get some money, okay, for their expenditure. So in that case they don't feel burdened to come and do work here.
Yes, sir. Thank you very much, sir. You share the detail. I will ask my student to
No,
apply
no,
for
that
summer
is
research.
there. You just type the summer research fellowship, not by SVNIT,
Okay. INSA.
in INSA,
International.
INSA. Yeah, INSA.
INSA, our students used to apply for that, and some most
Okay.
of the time they are getting one or two students are getting.
Yes, yes, yes.
Okay.
Okay, even like your, as I said, the semester dissertation project, like
Yes.
6 months project, so they can come and work, no problem, no issue.
Yes, sir. Yes, sir. This time we will send, hopefully that problem, corona problem solved. So we will send some student, at least 1 or 2 student to your
Sure,
place.
sure. Welcome.
Okay, sir. Thank you, sir. Thank you for your support.
Yes.
Our MSc student. Hello.
Yeah, yes, sir.
Sai Aishwarya, Dhyaneshwari, Satya, Satish Kumar. Our MSc students.
Yes, sir.
Okay, if you have any doubt, he said na, you can do the project or there itself. If you have any doubt, any clarification regarding that fellowship or internship, that also you can inquire na.
Oh, sure, sir. Yes, sir. Okay, sir.
Okay, okay.
Okay, sir.
Yeah.
I think there are no more questions.
Okay, madam.
Sir, Ishwar, sir,
Yes, ma'am.
can
Okay.
we go for good luck?
Okay, okay. Thank you so much, sir.
Welcome.